We are on day 21 of geometry now, and today we're starting unit 4 about circles. So I gave you 2 handouts today. One of them looks like this, and the other one was a do now activity. So before we do the do now, we'll just look through this handout and make sure that we understand all the bits and pieces since you didn't write them, but they are here. So first of all, we have a circle right here. This is the center of our circle. And basically, a circle is a center point and then a million little points all around that center point that are all the same distance from that center point. Now, that distance to the center is what we call the radius. So the radius is the distance from the center to the outer edge, and this is exactly half the length of the circle. So what we're talking about, the full length of the circle, that would be our diameter. That goes through the center and measures the distance from one outer edge to the other. So there's 2 formulas above diameter and radius. And that says, for example, the diameter is 2 times the radius, because that radius is half of the diameter. So if I don't know the diameter, but I do know the radius, and I want the diameter, I can take the radius times 2. If I don't know the radius, but I do know the diameter, I can divide the diameter in half, and that gives me the radius. The other few things, we're going to be looking at area and circumference today specifically. The area is the same as all the other shapes we've been doing. It's just the space that the shape takes up. It's the space inside the circle. And the formula for the area, we're introducing a new term, pi times the radius squared. Does anybody know what pi means? Yeah.
Equal to 3.14.
Yes, it is a number that is equal to approximately 3.14. So that's what pi is. Yes.
Would also make all of our answers approximate.
Yes, all of our answers are approximate. So we're not going to use 3.14. We're going to use a key that allows us to enter all of the decimals that are not listed here, because pi is what we call an irrational number, I believe, which means that this decimal goes on forever and ever and ever, and it never ends. So the other thing is circumference. This is the same thing essentially as perimeter. It's the distance around the shape, but with circles, we call it circumference. There's 2 different ways we could find this. If I know the radius, I can take 2 times pi times the radius, or if I know the diameter, I just take pi times the diameter. And then we won't focus on this aspect today, but it is good to know that a chord is a line segment that is touching, I guess I didn't finish writing that definition. Okay. Well, it touches 2 random points on the circle, and it goes through the inside of the circle. This is not any set length. This is something that we can find, though, depending on where it is touching our circle. So let's look at the do now problems. For number 1 and 2, you're going to find area and circumference. So the first thing I'm going to do is I'm going to write my formulas on a sticky note just so that I can carry them over to this page. So area equals pi r squared, and circumference equals 2 pi r, or pi d. Now, before we can do all this, everybody needs a calculator, because we're going to type the pi key. So if you do not have a calculator, go ahead and get one now. That way we can get familiar with how to type pi in without having to type 3.14. So on your yellow calculators, it will be just like this one I'm showing you on the screen. Pi is in light blue right above this arrow key under the clear button. So to access the blue keys, remember you just press second up arrow. And there is your little pi. So I'll clear it. Second, hit the up arrow. If you want to see the full value of pi, or as much as will display on the calculator, you just hit enter, and I can see 3.141592654, and so on. I want to make sure everybody can type in the pi button before we move on. Give me a thumbs up when you got it. Perfect. Thumbs up when you've got this typed. Perfect, thank you. Perfect. Everybody got that? Good. Okay, so let's use that to find number one. First of all, I've got a circle here, and I have a measure of 8 centimeters. Is this measure a diameter or a radius? It's a radius. Good. It's just half. Half is the radius. It's always going to be the smaller one. So to find area, what would I type in my calculator? Yes, pi 8 to the second power. Now what's nice about pi and radius squared, like this whole formula, you're not going to have to type in your times or anything in a certain specific order. You can type it in exactly how it looks. I'm going to move, oh my goodness, this happened yesterday. I'm going to move this down and write exactly what we will type. I'm literally going to type in pi 8 squared. That'll look just like this. Second, pi 8 squared. I don't know if anybody can see that. Hit enter, and I get 201.0619298. So there's that. Now this is because we're using pi, and we know pi is irrational. This goes on forever and ever and ever. Technically, this is an approximate answer. It will never be perfectly exact. The way to make it perfectly exact is kind of a simple fix. What we do is, instead of getting the decimal, first I'll write this. I'm going to write approximately 201.06 centimeters squared for the area. But if we wanted to give an exact area, we wouldn't include pi in the calculations. We could just find 8 squared, which, what is 8 squared? That's 64, right? I remembered that from in high school. 8 and 8 went to the store to buy a Nintendo 64. That's how I remembered that one. So
I remember it now that you said it.
right. So we have 64 pi. This is the most precise way to write the area. Yes.
So are we only using calculator pi, or can we plug in 3.14?
You could plug in 3.14. Let's see how that would change our answer. It's a bit different. So let's see.
96.
Okay, 3.14 times 8 squared. Yeah, it's not. Yeah, I want you to use the pi key if you're going to type it in. Don't just do 3.14 because then you're missing quite a few places. Your answer is going to be off by at least 0.5. In this case, it's off by, gosh, almost a full, it's off by a decent amount.
21.
Yeah. Yeah, 0.1019298. That's how much it's off by. So definitely use the pi key. But if I wanted to give an exact area, I would say 64 pi centimeters squared. So both answers are good. If you don't want to have to type in pi, you could just write pi. This is the most accurate answer technically, but this one makes more sense. We would use 201.06 more in a real world situation. Imagine I had a garden, and I measure half the garden, and it's a circular garden, it's 8 centimeters, and I'm trying to figure out how much mulch I can put inside of this garden. I think the landscape people would look at you crazy if you said, I need 64 pi worth of mulch. Say what? I need 201 square centimeters. That makes more sense. But this is more exact. It depends on what context you're in. So in real world context, obviously the numbers make more sense. But in a lot of testing, like if you go on to college or if you're taking tests for, I don't know, a sort of like a trade or something, sometimes you have to take a math test. Sometimes they want the exact answers without approximation. Anyway, let's move on to circumference.
That worked.
What'd you do? You did something different?
No, I was just seeing how many decimal points I needed.
Ah, okay, I get you.
3.1.
Gotcha. What did you find ended up working without using the pi key?
5 seems accurate enough.
14159. Okay, so let's try 5 decimals. 14159 times 8 squared. Hey, that is pretty accurate. Okay, so how about this? Instead of just 3.14, you're getting a pretty accurate answer with 3.14159. So if you're not going to use the pi key, you have to use 5 decimal places, at least. Because if you just use 3.14, your answer will be wrong. Okay. So to find circumference, I've got 2 circumference formulas. Which one am I going to use? 2 pi r or pi d? Yeah, 2 pi r. We have a radius.
Well, I mean, you could use D because diameter is literally just the radius times 2.
Okay, perfect. So actually you could use both. So if I wanted,
You know both.
exactly, I know that the radius is 8 centimeters. So quick math, what would the diameter be? 16, because 8 plus 8 is 16, or 8 times 2 is 16. So circumference, if I wanted to not type anything, I know it's pi d or diameter times pi. I could just say my diameter is 16. So my circumference is 16 pi centimeters. That's an exact answer. But let's type that in and get a decimal. So 16, second up arrow, there's my pi. Enter. And I got 50.2, I'll round up to 7, 50.27. So for these, remember the area is always going to be squared because it's not a length, it is a space. It's a space that is 2-dimensional. Circumference is whatever the units you started with, it stays that way. It won't be squared because we're just measuring a length around the circle. That's a one-dimensional measure. Questions about number one, or is that pretty straightforward? Feel like we got it. Okay, let's try number two. I have a circle with a measure of 10 feet. Is that a radius or a diameter? Diameter, good. Ah, good, good, good. So if the diameter is 10, I'm going to need the radius to find the area. And we know the radius is half. So the radius is 5 feet. So now that I know the radius, how do I find area? Yep. Pi 5 squared. Type that in. Second pi 5 squared. I got 78.5. I'll round up to 4. 78.54. And what would my units be? Feet squared. Good. Which sounds kind of funny. In real life, you would say square feet, but in all of our units of measurement, we always say squared last. 78.54 feet squared, or square feet. Okay. What would my exact area be without typing it in? And when I say exact, I mean using pi without decimals. So that's an example of an exact area. We just did the radius squared was 64, and we put pi on the end. Yes, yes, the area here would be 5 squared is 25 pi. So this is the exact area, 25 pi feet squared. Good. That's the exact measure. How about the circumference? Pi times the diameter. What is the diameter? 10. So for exact, I'm just going to write 10 pi. Feet. Now we'll type it in and get an approximation. 10 pi. And I got, oh, I should have known. You just move the decimal over. 31.41592654. It's just pi with a decimal place moved. That's what happens anytime you take something times 10. You're just moving that decimal over. So it's 31.4. I'll round up to 2 feet. Circles are nice because there's not too many things to decide about them. Finding area in circumference, as long as you know the formulas, is not too time consuming. You can do it very quickly. Okay. So now let's go in the opposite direction. The first two questions, I gave you a radius and a diameter, but now I'm going to give you an area. So for number 3, the area of a circle is 250 meters squared. I know area is pi times radius squared. So let's write a formula. I'm going to write A equals pi r squared. And I don't know my radius, but I do know my area, don't I? The area is 250. So why don't we replace A with 250? So I have 250 equals pi r squared. So now I have an equation, and we're going to solve for radius. We're going to solve for r. Now remember, whenever we're solving an equation, we're kind of doing the reverse order of operations. So I'm just going to remind us what that means. That means normally the very first thing that we would do whenever we see multiplication, exponents, blah, 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 is we do the exponent first, and then we do multiplication and division. And then we do addition and subtraction. But if you remember, whenever we're solving an equation, we go backwards. We get rid of addition and subtraction. Then we get rid of multiplication and division. And then if there's a square, we would take the square root. Maybe that's ringing a bell. Maybe not. We'll run through it. We're going to go in the opposite order. So there's no addition or subtraction here, right? Is there multiplication or division happening here? There is. We have pi times radius squared. The squared is an exponent, so we're not going to mess with that yet. Let's get rid of pi. How do I get rid of multiplication? Divide. So let's divide both sides of our equation by pi. Now on the right side of my problem, my pi's cancel. On my left side, we'll do an approximation. We'll get a decimal number here. So I will type 250 divided by pi. And I got, I'll let you guys type it in too. Type that in and make sure you get the same answer as me. I got 79.577471155. I'm going to round. I won't round up yet. I'm going to leave 3 decimal places this time. 79.577 equals what comes down on the right side.
R2.
Yes, R2, radius squared. So now I have 79.577 is equal to the radius squared, but that's not what I need. I just need radius by itself. So how do I do that?
Square root it.
Square root it. Good. So to get the most exact answer on your calculator, and tell me if any of your calculators won't let you do this. We're going to start by hitting the second button, the square root button, which is that x squared down here by 7. And then instead of typing that in, I want you guys to try to arrow up and highlight that 79.5774155 or 47155. Try to highlight it and hit enter. Will any of yours not let you arrow up? Some of them don't.
It's always easier on my phone.
Yeah, your phone's easier.
Well, that's useful.
That's nice. Less typing. So once you arrow up and select it, hit enter, and there you go. That's your answer. What did we just find? We did the square root of both sides, right?
Be the radius. Right?
That's the radius. Good, because the square root cancels the square and leaves us with r by itself. And we got 8.92062058. I'm just going to write 8.92. And that's my radius.
Sorry, make it a little compliment.
Oh, you're fine. Go right ahead. Okay, was everybody able to type that in their calculator properly? Good, good. Okay, so the question was, if the area is 250 meters squared, what is the radius? We got 8.92. What would the units be?
Meters.
Meters. Perfect. 8.92 meters. And now that I know the radius, how would I find the diameter? Sometimes it helps to draw a picture. Here's my radius, 8.92 meters.
Since the radius would be basically half of the diameter, wouldn't it just be you add both two sides of that together?
Yes. Yeah, that's perfect. Because the radius is exactly half of the diameter, I can just take that radius times 2, or I can do the radius plus the radius. That gives me the diameter. So I'm going to write here, that was my radius. And then in a different color here, diameter, it's just 8.92 times 2. And because we already have all these decimals on the calculator, again, to get a more exact answer, don't type 8.92 all over again. Just type times 2. And you'll see it says ANS times 2. That just means it's taking the answer times 2, which the calculator isn't showing it, but these decimals go on forever. So this is the most accurate way to do it on your calculator, even though it will still be an approximation technically because we used pi. So enter. What's our diameter? Good, 17.84 meters. Yes, perfect, perfect, perfect. So my diameter is 17.84 meters. Wonderful. That's not so bad, is it, you guys? Not so bad. All right. Wonderful. So that is area and circumference, diameter and radius. We know a few new things. We know a few new things. So here's what we're going to do. We're going to put this to the side and we will take a few notes and we're going to talk about angles and circles. Yes.
Really not using a tilde for
You-
the answer this time.
Oh, a tilde. We absolutely really should, because that means approximately, right? Now, whenever you use one, were you taught to put it at the beginning of the answer or at the end?
Somewhere at the end.
Somewhere at the end. Okay, so Dustin brought up a really great point. If our answer is not exact, like up here where we have 64 pi, like this is an exact answer. It's a number. There's not repeating decimals. If we don't have an exact answer, just like we do down here, we've got decimals, we're going to put this little squiggly at the end. This little squiggly. And I'm going to say it wrong. It's a tilde. Tilde.
I believe that's what it's called.
I know. Let me look up how to pronounce it because I don't want to be saying it wrong. I always forget. Let me pause. Okay, we looked it up. We're just going to say tilde. Tilde.
You want it to be so accurate. Like, yes.
I guess so. It is. It is. It's necessary. Bring up a great point. Okay, so let's take some notes. Let's take some notes. I'm going to title my note page as Geometry Unit 4. Circles. And today is, we say 21.
You know, we started talking about the subject earlier and my head's itching.
Oh no. Better be placebo. Day 21 notes. And again, we'll put the date on there. Today's date is September 9th, Tuesday. So, what we will actually need for the next part here is a compass. Because our compass is literally our circle maker. That's what these things are built for. They're built for drawing perfect circles where the point is our center point. So there should still be compasses at your desks. If not, I know there's plenty at the front of the room. Do you guys have them? Okay, good. All right. And then I'll zoom out. What I am going to do is have y'all draw a decent sized circle. And I'm going to open up my compass so that it's like this. Well, let's see. I want to make sure that it's not going to go off my page. So I'm just going to check. I'm going to find kind of a central point and make sure that my pencil won't go off the edge of my page just by kind of twirling it around the page. Okay, yeah, that should be good. And then see how well I can do this. I'm going to turn my page. This is the cheat code. Don't turn your hand, turn the page. Perfect circle. Voila.
You know, you're a winner.
I made it really big, guys. But, you know.
Really want you to be able to see it.
Yeah, I want you to see it really well. Make it kind of thick too. It's a lot easier though if you just turn your page instead of your hand. It makes it really nice. And then I'll outline this in black or something to make it really easy to see. And then we're going to talk about angles in circles. Get a black marker. And we're using compasses to draw a big circle on your page. And then I'm just going to outline it in black as close to that edge as I can. This is where the circle gets less perfect. I would really like to get compasses that I can like replace the writing tool in. I could probably do it with these. I haven't played around with it too much. I suppose I could put colored pencils in them, but you know. Right, but my marker won't fit. Let me try. Let's see. How'd you do that?
Yeah, no.
You gotta be smarter than the tool.
I won't fit. I put crayons in.
Yeah, I could. I could do a crayon.
Yeah.
I'm thinking colored pencil, maybe.
Yeah.
How did you open that? Or use?
I'm already loose.
Oh my gosh. Okay,
It's
so
the
look at
same
this.
thing as a Holy Catholic.
Oh my gosh. Okay, so you can literally flip this open right here. from this. Okay, and then it slides right out, and then, okay, ooh, let me try this. Let me try one of my pins. I'm so excited. Oh, yeah. Scared I'm gonna break it. Oops, now it's really stuck in there. Let me try this. Yeah. And I like to, you really kind of want it to be close to the same length as that. Oh my gosh, this is revolutionary. Thanks, girl.
I was just looking at it. And I was like,
Let me just try this on a second page for fun. I'll go back to that page, but let me just see. Oh my gosh, guys. Oh, that's so great. Okay, I'm gonna be using that in the future. Love it. Yeah, it does help a little bit to have a longer pencil. Okay, back to this. So, first, let's see. Let me see what kind of angles we have here. This is in degrees. I don't want to tell you the wrong thing. Let me pause this for a moment. Okay, so let's talk about two different angle relationships that we can see inside of circles. So you will also want a ruler. And what we're going to do here is somewhere in your circle. Doesn't have to be anywhere precise or exact. I'm going to just do about like this. Somewhere going through kind of the middle. I'm going to draw a straight line like that in red. And then I'm going to create an angle inside of my circle by connecting to the same point here. This will be the angle, and the opening will come out on this side. So we are going to do this like that. And I'm going to make that even thicker. And we will say that this angle in the circle is, it does look like a Pac-Man. This is A degrees. And in circles, math gets a little weird because the length that is created in kind of the opening of this angle, even though it's not a line, it's a curve, we're also going to measure it in degrees. It's kind of weird. That's what's confusing me a little bit. I want to study on that before I tell you more things. But this length is 2A degrees. And it's okay if it's short because it really, the smaller your A angle is, the smaller that length is going to be. So it'll be proportionate no matter what. It's one of those things. You could have a really skinny, teeny, tiny angle. It'll be accurate. Right. Maybe it won't match my picture, but it'll still work. Now this angle right here is called an inscribed angle. It's inscribed. It's inside. So let's write right here. I'm going to write it in red. This is an inscribed angle. Inscribe. In meaning inside. Scribe gosh, if I'm remembering properly, I feel like that is some sort of, well, it sounds like scribble. I'm thinking it's writing, so it's angles that are written within the inside of a circle. So, inscribed angle, simple, simple formula. Let's say that I give you that this length here, the green length, we'll call that, let's see, I'm going to get my protractor out. Looks like the angle that I drew is approximately 32, 33 degrees. Let's go this way. If A, it's really tiny. If A is 33 degrees, what is this length opposite of, bless you, opposite of my inscribed angle? How many degrees would that be? My inscribed angle is 33 degrees. This length is measured in degrees as well. It's 2 times A. What would this length be? 66. Good, 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 good. So that's all we do. If this is 2 times A, let me get the right color. So 2 times A, well, A is 33, so it's 2 times 33, which is 66 degrees. Not too bad. 33 and 66. Simple things that we can do with that. Simple things. Now, this is going to be different from one other angle I'm going to show you. I hope that you drew this somewhat through the center. If you did not, that is okay, because the next angle we'll draw will go through the center. So find your center point somehow. Doesn't have to be perfect. I don't remember exactly where it is. I'm just going to put a dot here. I'll say this is my center. And I'm going to draw another angle right here. I'm going to put, but this time just go halfway. Basically draw a radius and another radius to create an angle that's in the center. So this is a radius. This is a radius, right? Because it's from the outside of the circle going into the middle. So we've got 2 radiuses. And we'll call this angle C. Then we'll highlight the length out here that the opening of this angle C is touching. And guess what? This is also C. This is also C. So whatever the measure of this angle is, the measure of this is equal. This is called a central angle. We can remember this is a central angle because the vertex of the angle, the point, is in the center of the circle. So an inscribed angle looks like it uses more of a diameter A central angle uses a radius. Bad. So if I told you that the central angle C is 42 degrees, what would this length be? The green C. If this is 42 degrees, what's this?
Variable.
It's not an inscribed angle. It would be. These are going to be, they're going to be the same. They're going to be the same. If blue C is 42, green C is also 42. Kind of weird, but it works.
You kind of formed like a perfect triangle. See it?
Lots of triangles. Where's my perfect triangle? Oh. Yes, if it wasn't a curved edge. It's nice. Okay. Okay. So these are two different types of angles that we will see that have kind of a relationship to that outer edge of the circle. And they're formed by these chords that we talked about. But guys, we're going to call that kind of the sneak peek today, because I'm going to be honest, I just don't feel great. I can feel myself feeling worse and worse as I teach. And I feel like my face is getting like hot, you know, when you're getting sick and I don't want to get you guys sick. So and I can feel it building. So I'm going to make you guys an exit ticket. You're welcome to go take a break, bathroom, drink, whatever you need. But I would recommend that y'all don't stay in here too long because I don't feel good. I don't want to get you sick. But here's our kind of intro to Unit 4. And I'm going to make your exit ticket. It's going to be very similar to the do now. But I'm going to add one of those angles in there as well. So feel free to take a break while I'm making this exit ticket. You're also welcome to watch me do it, but I will go and make copies of it right after this. I appreciate you guys being so understanding. I'm sure you'll never complain for being let out a little early.
You said they let us out.
I know, I really don't want to get you guys sick today. I don't know.
Yeah, I'm gonna need you to like cough right in my face. So I'll have to go to work tomorrow.
Right. Okay, so this is due Friday.
I'm gonna get as wet Mr. V as possible.
You got it. I try it with my pens. I hope it works. I don't think it will. I wish that the point on this was longer. That would be nice. Let's see. I fit this through. Okay, and 2. So for number 1, you're going to find the area and the circumference for this circle. For number 2, you're going to find the measure of the inscribed angle. So you're going to find x, and I'm going to give you that this measure, this kind of arc out here, is, let's say, about 7 degrees. Okay, and that is it for your exit ticket. So I'll run some copies of this. You're welcome to begin working on it, or you can just wait for the copies, up to you, but that'll be it today. I need to get a little rest.